This is the first of a 4-part series sponsored by Multistack on advanced chillers and chiller design. Everyone kind of remembers that AES was pretty well known for doing our lunch and learns, and with the COVID and things that are happening in the world, we stopped doing those lunch and learns. Well, we're back on doing webinars, and we're going to be bringing you not only multi-part series, but some individuals all throughout the year. So I'm really excited that Bruce Barrett and Multistack were the first to jump on with a 4-part series. The next 3 in this 4-part series will be on the following Thursdays at 11 a.m. Central Standard Time. I do want to let people know that we are recording this. And so we'd like to hold all questions to the end. And if you'll use the chat feature below, we'll address your questions at the end as time allows. The other good part about recording this is that we are going to be uploading this to our website, and we're going to be having recordings of all of our seminars on our website so that you can go back and you can relook at it, revisit those, or if something caught your eye and thought it was great and you want to share it with a colleague or something, you'll be able to point them in that direction. As you saw from the email, if you registered to attend these 4 seminars, all 4, you're going to be entered in a drawing for a Traeger grill. So I thought, what a great time for a Traeger grill, right? 12 degrees in Kansas City and 4 degrees up there. Maybe we won't go out and grill, but we will soon. And so instead of providing you lunch, we thought it'd be kind of cool to do something different with that money we would use for lunch. So in order to get registered at the end of this seminar, you'll have to fill out a little short survey. And then we're also going to be emailing that survey just in case you have to drop off a little bit early through the questioning. We'll send you that survey so that by email so that you can register that way as well. If your company has a policy regarding gifts, there is an opt-out button in the survey. Just click that opt-out button. I know a lot of government facilities and things like that, if you're working for the government, not allowed to accept gifts. It's no big deal. Please fill out the survey, just opt out. In the survey, you can also click for a PDH credit and a copy of the presentation. So I think without any more of me talking, I'm gonna go ahead and turn this over to Bruce Barrett, and we're gonna start learning about air-cooled, water-cooled chillers, MagLev. Bruce?
All right, thank you, Keith. Appreciate the opportunity. We've got about 40 minutes of content. I promise I've got my timer going, and that once we get towards the end, I want to leave enough time for Q&A. We've narrowed our focus over a series of, I believe, 4 events. Today is going to be our MagLev offerings, both air-cooled and water-cooled. And not only different products that we offer, it's wide-ranging now, but I think it's important to go over a little bit of the history as we progress. From there, we're going to go off a review, and you've probably heard it before, but I think it's important to review again. You know, the oil-free frictionless design gives you a lot of added benefits, the sustainability of no degradation of performance, a lot less components on those machines, and how important it is to creating new designs that we're applying today, given it doesn't have any oil. We're going to break it down into the air-cooled products. We're going to talk a little bit about the standard lift compressor, the new high lift compressor, and how that can be applied to different regions or territories, ambient conditions across the country. Then our water-cooled offering, again, multi-compressor, our brand new modular design, which has, because of its flexibility, has really caught some speed in the market. As well as adiabatic, MagLev condensing units, given that flexibility that we don't have any oil to worry about. So just a brief history of Multistack. So we started in '89 by 3 ex-trained executives, Dick, Monty, and Bill, and I was fortunate enough to know them back in my train days. That was a while ago. I spent 10 years at Train. They were let go by American Standard. They had a golden parachute, a pile of money. They wanted to run their own business, come up with new and innovative ideas. They bought the rights to Multistack from an Australian company. It started with 30-ton scroll modules. That's it, 30-ton scrolls in a modular format, and their business took off. Today, we've expanded our company greatly. We've got almost 500 employees. just short of 750,000 square feet of production space. That is spread out to 5 different locations. The main chiller manufacturing is done in Sparta, Wisconsin. I'm not far from that, working out of home at the moment, but I do go into the office often. Germantown, Wisconsin, we bought a sister company that does some airside products. Wooddale, Illinois, they build our shells for our shell and tube machine, so important for the discussion today. Cleveland, Ohio, another sister company that makes chillers that we can't build, like -40, super low temp, super high temp, CO2 machines, both large and small. So they're in a completely different market, high level process cooling, refrigerated cars, etc. And lastly, Montreal, Canada, we've got a small air handler division where our engineering is done up there, but our manufacturing is done in Sparta, Wisconsin. We did about $170 million in revenue as a group of companies, the lion's share of that being Multistack. The top picture is our training facility. So we bring in technicians. It's a full dedicated facility spread out. We're still doing classes right now for contractors to be able to service our equipment, both for our reps and independent contractors. The bottom picture, that is sunny. It's not representing today, but that's in Sparta, Wisconsin. That's our largest facility, about 400,000, 500,000 square feet of manufacturing floor. A couple jobs that we're very, very proud to talk about because of not only the scale, but the prestige of them. We've got the Apple headquarters building in California. It's 14 banks of modular chillers installed in 2017. They had a high consciousness for low refrigerant charge. They don't have any refrigerant evacuation in this building. They had a high consciousness for redundancy. So they can lose multiple compressors, multiple circuits, still have enough cooling for their facility. They wanted that redundancy, and that's why modular fits so well. My territory happens to be the central, so I cover east of the Rockies, west of the Mississippi. I just picked up Ohio and Indiana, but my single largest project in my territory is a company called Epic. They do medical records. You're probably familiar with Cerner. Their headquarters is down there in KC. They're the only 2 medical record providers. They're both doing really well, as you can imagine. This happens to be a geothermal facility, super high efficiency, 21,000 tons, all of Multistack. You're absolutely invited to come up to our plant. We can stop in Madison, Verona area along the way. They're very proud to do plant tours. It's mind-blowing. It's like Disneyland. They incorporate not only geothermal chillers, but a lot of mag-bearing chillers operating off the condenser water loop of the geofield. Extremely efficient, something like a 0.42 kW per ton plant efficiency. Pumps, chillers included, super efficient. Another thing, component of our business we're very proud of is our U.S. Department of State, where we provide the lion's share to the U.S. State Department, which includes embassies and consulates around the world, sovereign U.S. soil, over 330 chillers. We're now on all the continents. We just got a chiller last year in Antarctica, cooling equipment on a weather research base. So look forward to visiting that someday. That'd be fun to visit all 7 continents. I think this is important for a lot of people, given the time of COVID and job loss. We're the only 100% US owned and operated chiller manufacturer. The only. We're the only mag bearing producer of chillers in the US. We're very proud of that. We're proud of our affiliation with the US State Department. Federal buildings and such often have a made in USA component, and we comply in spades with that. Again, some important history that builds up what we know about magnetic bearing chillers. When we bought the rights to the Australian Modular company in 88, 89, Ron Connery was the inventor of modular chillers. In about 2002, he invented a small magnetic bearing chiller for HVAC. We were the test bed at Multistack for that product, obviously given our relationship with the same company. Brilliant guy, really thinks outside the box. It's ironic that he's also the inventor of two very impacting technologies that are in place today. This experience was not easy. There was a lot of pain and suffering, understanding that compressor, learning how to control it. With our modular platform, that led very well to how to build a platform to control compressors independently. I'll explain a bit more about that later. We happen to be on our 3rd generation of controllers applied to our water-cooled machines, our 2nd generation on the air-cooled. As you can see, very good graphics. You'll notice on the machine pictured on the left, it shows operational compressors. It shows heat transfer through the tubes. Very easy 18-inch touchscreen, large touchscreen that gives a lot of visuals and easier customer experience in the field. What makes our compressor controls so good and different, really different? The modular environment, we had to control compressors and stage them independently. We have a system demand that can communicate directly via Modbus to each and every compressor. We can operate different compressor sizes at different speeds, keep them safer, improve our transitional efficiency as air temperatures or condenser water temperatures or load changes. We can precisely control those compressors one-to-one. We're the only one that has the software embedded into our standard Flexsys controller. We call it Flexsys because of its flexibility. Seemed to go well. All of the other manufacturers have to bring a laptop and plug into that software to do any troubleshooting. We can do it all via the standard controller. There's remote connectivity available through VPN. A lot of shutdown buildings don't allow external access, but we can do some special things like a Wi-Fi card, a phone card, to do troubleshooting remote with the assistance of our factory or technician. We do a lot of accessory controls as standard. Pump enables, adiabatic condensers, tower bypass valves. We can add those via our Flexsys, our flexible offering, just adding more points that we want to control in our standard controller. Again, this is probably a rehash of what you've heard over the years. Almost every major manufacturer, barring one, offers a magnetic bearing chiller at this moment. It's really becoming the standard. Used to be the exception, and I believe it's more the rule now. When I look at market share results, I believe 80% of the water-cooled market below 1,000 tons is magnetic bearing. So that's a real shift. These mag bearings don't have the parasitic loads of some other components attributed to oil. There's no oil in their system. So degradation of performance over time cannot happen. And it's real. I'll show an example of that. Very, very low inrush. All these compressors have an inherent drive in them. Because they're frictionless, there's no metal on metal contact. It takes less amps to get that shaft spinning, thus very, very low inrush. That elimination of oil leads to very creative designs. And we'll talk more about that later. What's that mean for system design for chillers? 134A is our standard. Right now, there is no phase out date for 134A. However, we're prepared. We do offer 513A as a very easy clickable option. Make some small tweaks to the controls. The pressures are very similar. And a special 1234ZE option. That is quite a bit different. You need a lot more surface area to get the same capacity. Upper right-hand side is the compressor offerings that we have now. Coming out new is this VTX Danfoss compressor. It's about 350 tons. So we're excited about bringing that compressor into the family so we can get larger chillers faster with less compressors. There's no purge, units ship with refrigerant. A typical chiller, you can pump all that refrigerant down into your bundles. You can isolate compressors, pull it off. You don't need a separate container for it. This low refrigerant charge typically gets you LEED refrigerant credits. Simple diagram of the compressor. They're really light. A lot of aluminum construction, obviously with the magnets inside, don't want to interfere. So an average 200-ton compressor is going to be about 310 pounds for 200 tons of capacity. So it's really small when compared to a 200-ton screw, probably a tenth of the weight. Right now, there are some limitations on the voltage. 460 volt is the only offering. 208 volt won't exist for a very, very long time, but 575 volt is coming. When you've got oil-free compressors, you don't need a heater, a cooler, a pump, a reservoir, a filter, piping valves, etc. These are refrigerant-cooled, suction gas-cooled compressors. The drive still needs to be cooled off, but we don't use oil or water to do so. That is a differentiator between some other manufacturers that use condenser water and those associated maintenances required with it. It's been well documented through the industry and really through my experience. When you have oil in your system, whether it's air cooled or water cooled, your heat transfer properties will lessen over time. In other words, your approach temperatures from refrigerant to water side get worse. Well published in a lot of the trade journals. If you want the full study, go totally nerd out on impact of oil. I can provide that study. Again, it's an ASHRAE study. What they found in that study, it's almost a 2-to-1. So if you have double the amount of oil that you should have in your system, let's say it's 4%, you're going to have about an 8% impact on efficiency. So how does oil get into your system over time? Well, one, there's initial charge for oiled machines, and right off the bat, your chiller performance is going to be fine. But over time, that oil will stick to the striations on the outside of the tubes, which increase heat transfer, and plug those tubes. And that performance lessens over time. Your approach might go from 1.5 or 2 degrees to 4, 5, 6. And that's simple math. Again, it's the 2-to-1 impact from oil to refrigerant. The ASHRAE study, I mean, it's an old one, but it still applies. They found a lot of chillers that had 22 and 23% of their total volume of oil. That is an incredible amount. Crushing impact of the performance over time. How does oil get into the system? How does it accumulate? It doesn't come out of nowhere. People put it into the machine. So if your condenser is colder than your evaporator for a time, oil and refrigerant migrate to the condenser side of the machine. Your oil sump becomes dry, and the service technician has to fill it up until the sensor says, I'm full, I've got enough lubrication. You do that for 5 years, 10 years, 20 years, you've got a lot of oil in that machine. Air cooled, again, applies. When your air temperature is cold and dormant, refrigerant is going to find its way to the condenser coil. You can't have a cold start. You've got to continue to refill the oil reservoir to get that compressor properly lubricated. These compressors are extremely quiet. We do put them in our air-cooled machines in a insulated box to keep them warm and toasty with the heater, so the computer components don't get too cold. But again, it's still an impact of oil on performance in air-cooled machines. Low inrush, again, because the shaft is so small and does not have metal-on-metal parts, you just got to get it spinning. Now, they do spin at a high rate of speed. They're a dual impeller compressor, but it takes about 2 amps of inrush. That's less than a toaster to get that spinning. So your MCA, your electrical, should be very low as compared to certainly a Y delta starter with no drive, but even some variable speed screw compressors. A lot of energy companies penalize for peak kW use. You can size your electrical off the R run load amps of this compressor and not the inrush. Power factor is very strong, 0.90 or better power factor, standard on all these compressors. So you shouldn't need any external power factor correction capacitors if, for example, a government job might require it. What does that mean for low inrush? Well, we just closed the largest air-cooled job in our history. Is about $30 million. We were the highest priced chiller. We're the most efficient chiller. But when they started adding up the reduction in size for their generators, we now became the best value total first installed cost. So a 900 kVA to a 1300 kVA, it's not a percentage cost difference. It is massive, the larger you get for generators. So think about that. If you've got a generator, we're not going to be the lowest cost a lot of the time, but through payback and total install costs, we might get there. So Dan Foss now is the owner of the compressor technology out of Tallahassee. We built their chiller for their office complex. We're using the air-cooled chiller here with the high lift compressor. Now this one's obviously custom paint. They put some sexy decals on it. It looks really good with all their different compressor refrigerant options. They put a glass case over the top of the compressors so customers could look in and see how very little that compressor vibrates, near zero vibration. Proud to build, the manufacturer that chose us for their facility. One of the options that we offer today is an air-cooled mag bearing with integral free cool coils. It's important to note that this refrigerant coil and water side coil are integral. They're all one piece. The fins go all the way through. It's not a layover coil. So it's very easy to clean, hose out from the inside out and push dust, debris, cottonwood, etc. A lot of other manufacturers do a layover coil and they sandwich a water coil over refrigerant coil. You cannot clean in between those. This is an 11V. So it's close to 300-ish tons. We do go from 60 to 400 ton air cooleds. Again, larger capacity data centers, we might be able to go up to 550 ton, oftentimes because their leaving chilled water temp is around 58, 60, 63 degrees. So we can get a heck of a lot more capacity when the leaving chilled water temperature is higher. Again, just to reiterate, our integral free cool option is not layover coils. It's fully serviceable, fully isolationable on the water side and the refrigerant side. Higher short circuit ratings are available all the way up to 100K short circuit rating. Different coil options with coatings if you've got a coastal environment. Custom paint, as it shows in the pretty red picture there. And pump options on board are available. This looks at the other side of that machine, and I want to point out how easily accessible it is to get to those compressors. You could isolate a compressor. You could pull it all the way out via some simple lifting gear. Again, they're about 300 pounds. It's got electrical disconnects per compressor. If you look up on the coil, it's got water side and refrigerant isolation valves on there. So if there's a leak in the coil, you just pin that one down, you can still operate your machine. Again, on top, the ultra quiet EC fans are standard. Local Kansas City job we're proud of. This was using our kind of it still applies today, but we don't sell as much. I'll explain that later. This was replacing a 1,200 ton, 20-ish old machine. We did it with 12 80-ton modules, almost a fifth of the refrigerant charge given the new machine. Ultra quiet. They're now able to lease space out next to this mechanical room. The pumps are way louder than the chillers. The electrical or the energy savings was about 25-30% right off the bat. So real proud job we are in Kansas City, Pershing Square. Okay, so on to flooded machines. We go from 600 to 2,000 ton machines. We have long and short shell configuration. Short shell, those are a 5-foot shell with a max of 2 compressors. They go up to about 220 tons. So if you've got a small compact space, you need around 200 tons or less, that 5-foot shell option might be a good choice. Again, they all come standard with our Flexsys controller. In fact, I got to change that picture. It's now an 18-inch touch screen, all updated with the newest technology. Back to our controls. So we're able to control compressors one-to-one, which means I can put different size compressors on my water-cooled machine. I can put a 500, TT500, which is about 200 tons. I can put a TT300 compressor on there that's about 90 tons. build approximately a 300-ton machine that can unload to 18 tons. Even with warm condenser water, I can unload to about 50 tons. A lot of different applications, chillers, screws with single compressors, just can't unload as well. And they need a pony chiller to handle the warm condenser water, low load conditions. On the right, we've got a 1,000-ton machine, 5 200-ton compressors. It can unload to about 45 tons. That's incredible turn down. And to about 100 tons with 85 or warm condenser water. You think about this, it's a vacation weekend. You got a 1,000-ton chiller in that room. Your condenser water is not going to cool down in a hot Kansas City day over the 4th of July. You need that chiller still to turn down. We can do that because we're operating one compressor. Split chillers. We can go up to about 400 tons, 2 or more compressors, great part load values. It's super quiet. Again, if you've got a split chiller with your compressors, controls inside, they could be piped out to a dry condenser, refrigerant piping out to the condenser with standard EC fans. Again, refrigerant alternatives are already in play. So what does the split look schematically? Our controls, our compressors, our electrical is safe and sound inside. All those very critical components where it's much warmer than the Kansas City or Wisconsin winters. Refrigerant piping out to could be a dry condenser. Since I don't have oil, I don't have to worry about traps, angles, and much less about distance. We still have to size the pipe appropriately. Why do people do splits? They want to eliminate glycol from their system. That's number one. Your efficiency can go up 10, 15% with a 30% reduction or no glycol applied. Again, it's very, very quiet indoor chiller, very quiet outdoor chiller. Mag bearing condensing units. So you've got multiple coils, multiple circuits. We would control the expansion valves on a call for cooling in the space. We've got our super quiet compressors and condenser outside doing all the control of the air handlers. Right now we're doing 134A only for MagLev condensing units. We're limited there about to 100 tons of coils. We don't want to go any smaller than that. We want to be able to turn down to those smaller loads. We even got the cottonwood mesh there that we installed in the factory in this drawing, this picture. Another option, mag bearing splits with an adiabatic condenser. Now, split chillers in general, because we don't, we're actually making this system a lot more simple to control. We're decreasing the mechanical room footprint because we do not have a condenser water pump. We do not have a tower three-way bypass. We don't have controls to monitor the tower. We've got a open loop system, a once through water system that doesn't need water treatment with an adiabatic condenser. We happen to use Guntner as an OEM product. I believe AAS also represents the Guntner product as well. That system, if you total all of those components in the system, should be a lower first cost system. How does it work? Well, cross-section of an adiabatic condenser where fluid connections go. Again, city water can be untreated. That water does not touch the coil. It can be limey and scaly. It does not touch the coil. It absorbs into the media. There are refrigerant connections, obviously, from our chiller to the adiabatic. We can help out with that design as well. There's no Legionella risk given that water temperature is too cold for it to grow. So for the concerns of towers that need to be proper balance of chemicals and the Legionella concern, that's been eliminated. These are quiet condensers. Single condensers can go up to about 300, 350 tons for a single machine. How's it work? Well, I could have used Kansas City conditions, maybe 105 ambient, but as it passes through the media, it combines a wet bulb condition with the dry bulb hot conditions outside. The greater temperature difference that you have from ambient to your wet bulb is basically the warmer it gets, the better the cooling effect becomes. That's why they use swamp coolers in Arizona. The air actually hitting the coil is, again, a mixed temperature, wet bulb to dry bulb. That lowers your condensing temperature dramatically. I'd rather have 75, 80, 85 degree air hitting my coil than 105 outside. Reduces the amount of lift or work those compressors have to use. And again, just reviewing the differences between a cooling tower and adiabatic. They both work very well. You get a lot of benefits using adiabatic. No maintenance of those tower drives. They're typically maintenance-free motors, EC motors. No water treatment, again, Legionella. You do have to winterize. You don't want to leave your water connected, your city water connections, they'll freeze. You could blow those out in the wintertime. Pad replacement, it's based on the quality of the water, whether it's limey and scaly like what Kansas City typically is. Cottonwood, dust, you might have to change it every 3 years versus every 5, but it's a very easy replacement, almost like a cartridge replacement for your filter for your house. None of the winterization issues dealt with for a tower. It also uses dramatically less water. We only use it when we have to. So I ran a couple scenarios of chiller performance, and I'm pouring the coals to it. I'm using a lot of water in this application. The efficiency on the left here shows just chiller efficiency, the performance data that we generate. I'm driving that condenser to a design condensing temperature based upon my ambient and my wet bulb. The program does it all for me. Then I combined the performance of the chiller and the condenser to come up with a total kW per ton for my system. Of course, I'm not factoring the evaporator pumps. That's going to be the same tower versus adiabatic. A 792 kW per ton for an air-cooled chiller. That's unheard of. We look at the IPLV, we're up around 26 for an air-cooled chiller for an IPLV. When the day is favorable, when it's raining, you don't use any water. Only on those hot days when you're trying to drive down or force down your condensing temperatures. I found a lot of utilities both rebate full load and part load. So if there are KCPL or something like that offering rebates, having a discussion about this could mean a lot of dollars. All right, we're going to get in the weeds a little bit technically for you compressor heads out there. So lowering condenser temperatures is the name of the game. Compressors have to use less work to reject heat basically through our condenser. 125 degrees would not be uncommon for an air-cooled mag-bearing machine, but look at how narrow the operational map is up on top. I can only run these compressors in a certain range from 90 tons to about 120 tons. My optimal line from our manufacturer says, stay on this line, you're gonna have the best performance. If I start pushing down my condensing temperature, I'm starting to push it to the sweet spot. You know, the part of the bat that you hit that you can't feel anything. So that sweet spot for this compressor is around 105, 106, 107 saturated condensing temperature. And look at how wide the operational envelope gets. When I have multiple compressors, we're actually stacking this compressor map one on top of the other to build a larger machine. So it gives us way more operational map when we start compressing down saturated condensing temperatures. We also have a new compressor for our air-cooled mag-bearing and heat recovery machines. I'm going to save that for the heat recovery seminar. But this new compressor allows us to operate and expand the operating envelope all the way up to 145 degrees saturated condensing temperature. Applications like Arizona, where it gets 120 ambient, 115 ambient, I would use that compressor. Texas, when they see 45 days of 105 or higher ambience and it never cools off below 100, this is not the right compressor to use. That's where that high lift compressor is going to come into play. A new design that we've come out with is a modular mag bearing machine, 90 to 140 tons. I'm not going to steal a thunder. You just stack them together, victolically coupled. You can build a chiller. I'm going to start a little video, give you 2 minutes of video action. Something I'm trying. Looking forward to your feedback.
Hey everyone, thanks for joining for another Multistack Minute. I'm Bruce Barrett, your Central Territory Manager here at Multistack in Sparta, Wisconsin. Today's Multistack Minute is the Modular mag-bearing 90 to 140 ton water-cooled chiller. All right. One of the great features of this machine is it's less than 36 inches wide. You can get it through a 3.0 door. You can stack multiple machines together in a very small space and build a chiller well over 1,000 tons. Some of the great features: electrical isolation on each module to kill power there. Our unit subcontrollers that can be tied to the master. Looking at the side of the chiller, these chillers can be coupled together once brought into the building with a grooved coupling. Here we have our mag-bearing compressor, again 90 to 140 ton modules, our evaporator and our condenser. As standard, we provide on the refrigerant side suction and discharge valves. We can work on that in compressor. You can pull it off, isolate the refrigerant in the shells. As a standard feature again, hinged water boxes on both the evaporator and condenser with a 42-inch tube pull. That's about the aisle width. So great for a compact mechanical room. You don't need 20-foot tube pulls in pulling a 1,000-ton machine, for example. Moving on to the inside, the other side of the machine here, great feature that we just added are the refrigerant vent pipings. Stubbed out above the unit makes it easier for the contractor to install the refrigerant piping discharging out of the building. This particular order's got multiple machines, certainly going on the test end pretty soon. Again, this is your 90 to 140 ton modular mag-bearing compact water-cooled chiller. Thanks for joining for the Multistack Minute. Bye-bye.
Pretty cheesy, huh? All right, so just a quick summary. 90 to 140 tons. We can mix and match sizes. I can have a 90 and a bunch of 140s. I can have a 90, a 120, and a 140. Sky's the limit. They're super quiet, super compact, 42-inch tube pull. That's an aisle width. Redundancy, serviceability. You still have that excellent mag-bearing oil-free performance. Alternative refrigerants already in play. In fact, the one pictured here has alternative refrigerant in it, 513A. What else can we do? Well, as standard, we provide coated condenser and evaporator water boxes on our water-cooled machines. Standard, zero add. We coat the tube sheets as well. That's a real tight epoxy. It adds for longer protection of your shells. If you've got some gunk in the water, it's going to resist that much, much longer. The section in the middle there, PVC wrap is an option. We did this for the University of Hawaii. We cut their University of Hawaii emblem in it. It looks really good. More so, it keeps your shells and insulation really well protected on that cold evaporator side. Full ensemble of marine water boxes there on the right. You'll notice we've got a full unit disconnect and individual compressor disconnects, refrigerant isolation. We can do custom paint. We can paint it any color you want, match the equipment room, match the university, match the school. All of these options in the water-cooled format can be done with adiabatic or split chillers. Even the modular machine can be done as a split chiller. So you can have a compact design in your mechanical room. You don't need to go to a larger flooded machine. So quick summary, oil-free mag-bearing machines, they're just a different animal. We've been doing it longer. We believe our controls, given our independent compressor controls, do much better than other folks in controlling, especially at light loads, and transitional efficiency. Sustainable performance. If you keep your inside of your tubes clean, they should never be fouled on the outside of the tubes, given we don't have oil. We're the leader in magnetic bearing development. We're the only US mag bearing company out there. Very proud of that. We can get really creative once we eliminate oil, whether it be modular, adiabatic, splits, mag bearing condensing units. between AES and Multistack. We look forward to your questions. I'm gonna shut down the prezo at the moment. I'm gonna start looking at the Q&A, but certainly people can speak up by unmuting as well, I would guess. Right, Keith?
Yeah, I'll jump in here, Bruce. First of all, great presentation. Every time I hear you speak, I'm impressed. And every time I see the products, not only that Multistack's been doing for years, but that they keep doing, it's just exciting to hear what's going on at Multistack. I do have a couple of questions. One of them was early on. I think you addressed it, but let's just address it again. Can you talk about water flow rate turn down on your chillers, both flooded and modular?
Great question. So your typical turn down in a water cooled machine, I'm going to go back to the prezo just to show pictures. All right, let's talk about the modular first. If you've got multiple modules in an array on a variable flow system, you can typically turn down to 40% of your module's flow. So if you've got a 1,000-ton machine with a 10-degree delta T, that could be 2.4 GPM per ton, 2,400 GPM. But one of those modules, I can turn down to one module's worth of flow. So it could be 80 GPM out of your 2,400 ton of turn down. So tremendous turn down potential on the flow and your pump side. And I know you're a pump guy, Keith. Pump savings is big energy.
Not as big as the compressor, but big energy savings still.
When we look at a flooded machine, same rules applied. Typical turn down is 40–50% of your design flow. But one of the control benefits that we have is also rate of change. We have a 40% rate of change per minute that our compressors can adjust to. So if something shuts down the system really quickly, we can catch up with our compressors.
Oh, great. I've got another question here. It's from Melina. Have you seen an application or request from an owner where they want to run the condenser and chilled water through the chiller while the compressor is off until the condenser water is warmed up? Usually when the system transitions from water economizer to mechanical cooling. Just like to hear your opinion on that.
Yeah, so running condenser water through till it warms up and you can have enough temperature differential to start compressors and do mechanical cooling. I have heard about that. Usually when it runs through your condenser, you can't recover heat fast enough. So a three-way tower bypass is usually bypassing the condenser itself, but you can run water right through it. There are safeties on the chiller that, I should say control safeties, not on our chiller. We actually look at suction pressure, discharge pressure. Our chiller will say, I can't start, your condenser water is too cold. We usually have a controls directive to state what your minimum tower water temperature is, and then enable the chiller once that temperature gets there. But yes, you can run that through the chiller.
Great. So it's a great question. Bruce, we didn't have any other questions, which tells me that you addressed almost everything that people were thinking about throughout the presentation. I think it was absolutely fabulous. I just want to
Jim had a question. My audio did not come through. Was that on the video?
Yeah, we're going to fix that. And I've already told everyone, Bruce, that we're going to send them the video separately. So just as
okay.
We're going to send that video separately. And Bruce, we're going to tape over that for the tape, okay?
Good. I'm glad you didn't hear how cheesy it was. That's good.
So, by the way, thank you for one of our participants, Sterling, said it's a great presentation, wonderful information. But hey, this is just the start of our 4-part series. So we're going to wrap this up for today and let you know that next Thursday is going to be part 2 with Bruce again. It's going to be the Bruce and Multistack show. And if you'll fill out the survey, that'll get you registered for that Traeger grill. Sorry, Bruce, you're not registered. I can't let you have that one. But from here on out, guys, we're going to bring you a bunch of great presentations throughout the year. Just going to keep on pushing with this wonderful product with Multistack and what they're doing for advanced chillers. I did want to note that there's a lot of rebate programs, not only just in Kansas City, but other places. When you look at these high efficiency chillers, the energy companies are going to possibly give you a rebate immediately for going with a higher efficiency chiller, which will offset maybe some of that cost difference. We've seen that in multiple cases, and it's pretty exciting. And Bruce, I think you've seen it all over the United States, correct?
Right. Yeah, it's interesting. Like I'll pick on ComEd in Chicago. They have a separate rebate program for mag bearing chillers, oil-free chillers. And it's a lot more than a chiller with a VFD. So a lot of utilities are acknowledging that it's a different machine, the sustainable performance, the low inrush, that's what's driving those rebates.
Yep, and that new flooded modular, what a great product. We've got some installations going already, and that is a game changer in the modular world. So Bruce, I just want to say, I want to just chime in. I've got several other people saying the same thing. What a great presentation. We're going to shut it down now, and thank you all for attending. And we look forward to you all attending next Thursday at 11 o'clock Central Standard Time for round 2. Thank you very much. Have an awesome day.